Before you can effectively mitigate a risk, you need to understand it. And when it comes to electrical risks, that means having a qualified person conduct risk assessments. First, what do we mean by a qualified person? Well, in this context, a qualified person is someone explicitly trained and competent in electrical risk and mitigation. So they have the knowledge and experience to make sure their analysis is both accurate and comprehensive. The two assessments they'll need to conduct are an electric shock risk assessment and an arc flash risk assessment. Again, an electric shock is different from an arc flash, so the two are treated separate. An electric shock assessment focuses on identifying the risk of coming into direct contact with live electrical equipment. The assessment typically examines the voltage level and type of equipment in question. A qualified person can look at these factors and check the tables in NFPA 70E to determine the appropriate working distances and protective measures. From this assessment, we get two critical boundaries: the limited approach boundary and the restricted approach boundary. The limited approach boundary is the distance from energized equipment where there's a chance of electric shock, so only qualified workers are allowed inside this boundary. Even closer to the live parts is the restricted approach boundary. This is where the risk of electric shock is highest, so even qualified workers aren't allowed to enter this area unless they're insulated and wearing the appropriate gear. Now focusing back on arc flash. The arc flash risk assessment specifically focuses on identifying the likelihood, severity, and range of an arc flash. This helps us establish safe working distances and the level of protective gear that we need to wear. From this assessment, we could add a third approach boundary, the arc flash boundary. The arc flash boundary marks the distance where a person could still get a second-degree burn if an arc flash occurs. Now, a second-degree burn is treatable, but it's still not ideal, so more distance is always better. But anyone working within this boundary definitely needs to be wearing arc-rated gear in order to protect themselves from far worse. So to determine the arc flash boundary, a qualified person needs to look at multiple factors, like the voltage, the condition of the installation, its short circuit potential, and the duration and range of a potential arc flash. This process includes determining what we call available incident energy, which is the amount of energy that could potentially reach a person standing at a certain distance from the arc flash. That qualified person can refer to Annex D of the NFPA 70E, which is where you could find different calculation methods for setting the exact distance of the arc flash boundary. It's important to recognize here that the arc flash boundary might be smaller or larger than the limited approach boundary, which again is why we calculate these boundaries separately. Next, you'll need to determine the appropriate protective gear to be worn. Since an arc flash packs a serious punch in terms of heat and energy, we need serious gear to protect us. So arc-rated PPE comes categorized from levels 1 through 4, with 4 being the most protective. The arc flash risk assessment is what determines the exact category your gear needs to meet. Again, you can find tables in NFPA 70E to help you match the right gear for the risk. At any rate, you'll need to protect every inch of your body that might be exposed to an arc flash. That means head, eyes, ears, body, hands, and feet. You'll want an arc-rated helmet paired with a face shield, balaclava, or a hood to shield your entire head and face. You'll also want to wear safety glasses or goggles underneath, specifically for eye and UV light protection. Remember, arc flash is also loud, so you'll want arc-rated ear canal inserts to protect your hearing. Of course, you'll also need an arc-rated long-sleeve shirt, pants, coverall, or jacket to shield the majority of your body for greater protection. For your hands, you'll need either arc-rated leather gloves or insulated rubber gloves, depending on the arc rating requirement. But if you're using rubber gloves, you'll also need to wear protectors over them, just to make sure they don't snag or rip open on any equipment. Also, don't forget your feet. Arc flash happens in every direction, so a solid pair of arc-rated shoes is really important for full body protection. And if you find yourself needing a category 3 or 4 protection for a job, just be prepared to layer up with stronger or additional arc-rated gear to make sure you're fully protected. Now, what you wear underneath all that gear also matters, in case there's a tear or breach in your outer layer. That means you should wear flame-resistant fabrics underneath your arc-rated gear. But most importantly, never wear synthetic, meltable fabrics like acetate, nylon, polyester, polypropylene, spandex, or anything that can melt into your skin and cause serious injury or complications. Of course, the same restriction goes for things like zippers, jewelry, or other accessories that can melt. Also, a discussion on equipment wouldn't be complete without mentioning the tools themselves. Remember how an accidentally dropped wrench could short-circuit a high-voltage system and cause the one thing we've been trying to avoid? It's not just about protecting your body, but preventing an arc flash in the first place. So even if you're already insulated head to toe, your tools need to be too. That means everything from your screwdriver to your portable ladder. Anything that could come into contact with live equipment should be rated for the voltage you're working with. You should also inspect them for damage before every job to make sure their insulation is intact. Okay, you've completed your assessments, defined your boundaries, and determined what PPE and tools are required. Now you need to communicate the results directly on your equipment with safety labels. These labels help your team quickly understand the risks involved and make decisions based on their safety. At a minimum, these labels need to include the nominal system voltage, arc flash boundary, and either the available incident energy and corresponding working distance or the required level of PPE. It's also good practice to include any other helpful information, like the limited and restricted approach boundaries. Lastly, equipment labeling is the responsibility of the equipment owner, not the manufacturer, so it's important to take the time to do it right. The NFPA also requires that you update your assessments and labels anytime there are changes to the electrical system or the equipment conditions change, and at least one time every 5 years to keep things up to date. Now that we understand the relevant risk assessments and what we can learn from them, let's talk about putting their results into action when preparing for a job.